Hi everyone, welcome back to the day 4 of our Python problem solving series, and today we are going to focus on basic array problems. So for this video we just need for you to have some knowledge about if else conditions and loops in Python, and of course the array data structures, which is the basic. So that's all that you need, and today we will try to solve these problems in minimum and optimize time and space complexity, and we'll get to know a lot of different algorithms as well. So let's just dive right in. Okay, so we will start from the easy problems today. The first one is largest element in an array. So I think this is fairly simple. So 187, 56, and 90, that's what we need. Okay, given an array R, the task is to find the largest element and return it. So we have to think about the less minimum time complexity that we can achieve with this. So what we can do, we can absolutely, let's say, sort the array and then take either the last element or the first element based on the type of sorting that we are doing. But the sort function that we use in Python, that basically takes time complexity of n log n. So if we can do it in O of n, then why shouldn't we try that, right? So even if the code looks longer, I think we should go ahead with the minimum time complexity achievable, right? Okay, so let's start with that. We can just give a normal for loop within range of, let's say, length of r, right? And if we can take a, we can take a variable saying max, which is maybe very low. Is this going to be positive or, yeah, this is positive. R of I is 0. Okay, then we can take as 0. So if only one element, then we'll just return that. Largest is that. Duplication, then that only. Okay, so if r of I greater than max, max equals to r of I, and then we'll just return max, right? So that's what it is. This is O of n. Let's combine. This is a simple problem. Okay, great. So all the test cases passed. That's good. Let's move on to the next question. The next question is second largest. Given an array of positive integers, return the second largest element from the array. If the second largest element does not exist, then return -1. When can a second largest element cannot exist? So either there's only one element or 0 element in the array, or let's say all the elements are same. So eventually everyone is the highest element, largest element, right? So, okay, those two can appear, but even then, I think we should go ahead and maybe take 2 pointers here, max and second max or something. Second highest, second high, 0 and 0, both. We initiate to that. Okay. Oh, if the largest element of the array is 10 and the second largest element is not there, then we will return -1. We'll just return -1. So how do we do it? Second largest element. We can sort it. So let's just try to sort it first. So add dot sort. So add dot sort will sort it in ascending order, and then we'll just check if of, let's say, -2. Oh, we have to take the largest element. So let's start from there then. So for I in uh, range of, so length of r minus 1 comma minus 1 by 1, then what will we do? We'll just keep on checking if, or not minus 1 per se, you can take it to be 0, and I'll tell you why. So basically, if r of I is greater than r of I minus 1, right? So this is essentially, let's say 1 till 1 we are going, and then after that r of I minus 1 will take care of it. R of I greater than r of I minus 1, then return r of I minus 1 immediately and break. Otherwise, return minus 1, right? So this is not greater than r of I minus 1. That means all the elements are same. So then we will return minus 1. So let's just check this. And we have started from end. We've gone till 1. Okay, r dot sort is fine. Sorting in place. Length of array minus 1 to 1, and we will skip the steps, loop iteration basically by 1 step each. Now if r of I greater than r of I minus 1, that's just true. Oh, this is not minus 1. This is not plus 1. This is minus 1 actually. Let's compile. Yep. Okay, it failed. Your code's output is minus 1, but correct output is 5. R of I greater than R of I minus 1, then return R of I minus 1. Oh, I think we should do something like this. 0. Now this will run because array will essentially go till the last position, last but 1 position. So if it's 1, then it's going till 2, and that's it. It's not comparing for the last one. What? Code's output is 34, 34. Sorry, that's bad. Don't need this. Compile, please. 5 and 5. Okay, let's do it. Great. Okay, so problem solved. But this is essentially in n log n. So let's try and solve this in O of n. All right, so what I'm thinking is, okay, so let's take 2 pointers, maybe something like max r, which is maximum element or largest element, and then take the second largest element, right? So I think that's fine. It's going till 1 through 10,000, sorry, 1 lakh. So we are good. We can take this to be 0. So let's just try and find out the highest element here. For I in range, length of r, if I is greater than r of I is greater than max r, then max r equals to r of I. So we have the max element here. Now we can run another loop for I in range. So this is basically n plus n, which is n only. So r length of r, okay, for I in range length of r, if r of I greater than r And we will need another if, or we can just do an and max r is greater than sec lar, then sec lar equals to r of I, right? And then we can return the second largest element. So essentially what will happen here, so the second largest element will always be greater than everything else, but only will be lesser than max array, which is the maximum element. And uh, we can return that, and anytime if there's not a largest element, sorry, second largest element that exists, then we can return either second largest or -1. Hmm. So this is -1. Second largest would be -1. And yeah, we are good. If it's replaced, 5. Output difference is, my output is 10. Okay. So if R of I is greater than second largest, which is true, yes it is. Second largest equals to R of I. And max R greater than second largest. And max R greater than R of I. Sorry. Then we can take this. Otherwise, we cannot take this. Yep. This is fine. Cool. Okay, so yeah, this is another solution that you can take. This is being done in O of n. So let's move on to the next question. Check if the array is rotated. So given an array, return true if the array was originally sorted and then rotated. 3, 4, 5, 1, 2, true. Yeah, because it was rotated. 2, 1, 3, 4, it was never rotated. False. Yeah, okay. 1, 3, 4. 1, 2, 3, it's already rotated. That's fine. Okay, great. So what we can do, so essentially if this is rotated and broken down in the middle, so we can check if at any point in time, the earlier element of the array is lesser than, greater than the next element of the array. That means there's a break. If there's a break, then we can take the last one in front and the second one, first one at the end, and then we can combine or concatenate those. Here also, let's say 1 is lesser than 3, that's fine, but 2 is lesser than 2 is greater than 1, but even if I break it down 1, 3, 4, 2, no, this is not rotated. So if this is equals to, okay, this is true or false. So we'll just have to compare with the sorted array, I believe. That's good. Let's just do this. For I in range length of nums. So I'll just walk you through all the steps. So what will we do here? First, we will find out any particular pivot point of the array where the earlier element is actually greater than the later element, right? So if, what's happening? If r of I less than r of I plus 1, not less, greater than r of I plus 1, then we will break it there. Break, right? So come out of the loop. Else return true. No, not return true. Else then continue and then basically return true, right? Yeah. Okay, if I break here, I is greater than I plus 1. That's bad. That's not possible. This is in non-decreasing. That means increasing order. So we will break it we will break at this point and then we will return the I. Otherwise, if it goes on, if R I is always less than R I plus 1, then continue basically, else continue, and then we can return true. Once this is done. If equals to length of nums minus 1, length of nums is 6, and that is I equals to 5 or 4. Then we can return true. Yeah, this is not needed. Okay, this will break, and once it breaks, then we will return maybe r of I plus 1 through the end, and then r of 1 through I plus 1, right? Because I is the breaking point. So I plus 1, once I is greater than I plus 1, which is here, and then I plus 1 through the end will be the first portion of the array, and the next portion would be the still I plus 1. Yes, perfect. And if this is equals to sorted of or not. If it's true, then yes. If not, then it will return false. Yep. R is not defined. Oh, sorry. This is nums, not R. Okay. Submit and check. No, I where it is not associated with the value. Okay. That's fine. That makes sense. Can we take a breakpoint or something? Point. Let's take this point to be 0. And then if nums I greater than this, then point to be I. Then we can say point, and this also can be point. So I is a loop variable. Accepted. Cool. Okay. So we're done with the third problem then. Let's move on to the next one. Remove duplicates from a sorted array. Okay, so remove duplicates from sorted array. Given an integer array, non-decreasing order, remove duplicates in place. Okay, so 1, 1, 2. So this 1, 2, and consider the number of unique elements of nums to be k. To get accepted, you need to do the following changes. Change the array nums such that the first k elements contains the unique elements and in the order they were present in nums initially. And this is non-decreasing order. So yes, they were sorted basically. The remaining elements of nums are not important as well as the size of nums. Oh, those are not important. Nums can be 100 and then the unique elements could be 5. So I'll be returning k. K is 5. Got it. Okay, okay. So can we do something? We have to take pointers here, I think. So let's take an example. So if it's 1, 1, 2. So if this number, and this is also sorted in non-decreasing, yes. So 1 and 1, if this equals to next number, then we'll just go ahead and then we'll just keep on repeating whenever there's a mismatch. 1 is not equals to 2. 2 will eventually misplace or replace the earlier step where it was 1. Yeah, so this can be essentially 1, 1, 1 and then 2. So first element is fine. I think we will start from 1 always, and then we will replace that particular element. And rest can be anything. Yeah. Okay, I think I got the essence of it. I think once I start coding, you will also understand. So just again, just to give you a better understanding, what I'm trying to do here is, let's say if you have 0, 0 and then 1, 1, 1. So essentially this 1 should come in here and then this 2 should come in here, right? So what I'll do, I'll start from array position of 1 itself, because the first element, this is always sorted. So the first element will always be the smallest one. If the next one is equal to the first one, then we'll just move ahead, right? But I will keep another pointer at this point because I'll have to replace this element, because it's the same with the earlier one. So I have to replace this. So once I get a mismatch, the element is not equals to this one or the earlier one or earlier ones, then I will take that, replace it to this particular pointer, whatever I've taken, maybe point or starting point or left or whatever, right? So I will replace that, and then I'll keep on increasing that one by one, and then there'll be another loop variable which will continue traversing the loop and finding out each distinct element, and then replacing the particular pointer which I've taken earlier. Hope this is clear. Let's just move ahead, okay? So for I in Oh, I need another pointer. Let's start start point. So start point to be 1. I think 1 is fine. For I in range 1 comma length of nums, okay? That's what it is. If nums of I equals to nums of I minus 1, then continue, right? Then continue. I would be plus 1. But else nums of I, not I, nums of start point equals to nums of I and move on. Start point plus equals to 1. So yeah, that's it. Then how do I get the unique elements at the end? So okay, let's traverse this. So 1 will replace here, then it will keep on going, keep on moving forward. This is same, this is same. This will be different. So 2 will be replacing this, 3 will be replacing this, and 4 will be replacing this. And after that, even if there are string of 4s, start point won't be increasing. Start point will be till here only, 0, 1, 2, 3, 4. And that is the length. I think so. The return point would be start point plus 1. Start point plus 1, because I have replaced these. Start nums of start point equals to nums of I. So that's fine, and return start point plus 1. I think this is fine. Let's just go ahead, because that will just give you the length of the unique elements. No, it's not correct. So output is 1, 2, 2. 1. But we should return integer, right? Why is it taking an array? Okay, should I return the array? That also something I can do. So that will be nums of start point plus 1. Yep, that's 1. Let's go ahead, run. Plus is not valid. Oh, yeah. But what? No, we can do that. This basically. One, two, two is not valid value for the expected return type integer. So we're returning integer only, no? Start point plus 1. Okay, something wrong. Should I change the array num such that first k elements of the num contains a unique element? Oh, okay. I think this will do. I got it. So this particular start point, they're taking it and then placing in the array and sharing the elements within the array. Yep, cool. Okay, got it. So this is nothing but not the length of the individual elements, but rather this wants you to tell the position till where there are unique elements within the array that you have sorted. So okay, that's it. Let's move on to the next question. Okay, so here we'll have to rotate the array in place, basically. We have to rotate the array in place, and we should not return anything, modify nums in place instead. So what we can do, first of all, if we have to rotate by 3 times and 3 is greater than the length of the array, then essentially we'll have to take a mod of the number k divided by the length of the array. So let's just do that. K equals to k mod length of nums, right? So that's all that is. Okay, so we will have to rotate the array in place. Nums is this and k equals to 3. Okay, we have to rotate by 3 positions basically. So 1, 2, 3, 4. If it's rotated by 3, so 5, 6, 7 will come first, and then 1, 2, 3, 4 will be at the end. Okay, got it. So what will we do? First, let's take the mod of k by length of array. Why? Because let's say if it's 30 and your length of array itself is 7, which is much lesser than 30, so you won't necessarily rotate the array 30 times, right? But rather, essentially, you'll rotate the array 2 times, which will give you the same result as rotating it by 30 times. So that's it. Let's take that. Now you will have to, what I will do, I will take a reverse of the array. So first 1, 2, 3, 4, 5, 6, 7 will become 7, 6, 5, 4, 3, 2, 1. So let's just do that. We can do that in place. Nums dot reverse should not hold this value anywhere because these in place sorting function or reverse functions actually returns non-type objects. So instead of that, what we should do, first we have reversed and then we have to again reverse the first section and the second section. So this is, I think, one of the most efficient methods to rotate in place. What should we do? Basically, first we are reversing the whole array 7, 6, 5, 1, 2, 3, 4, 4, 3, 2, 1. And then after that, we'll just rotate the first 3 elements again, the point basically, and then the rest of the elements again. So how will we achieve that? Let's just replace the first k elements by their reversed versions, right? So again, k till this would be, and then we can return nothing essentially. Let's check. Yep, accepted. Let's submit. So we're reversing the array twice. Nobody submitted, is it? No. Okay. Anyway, so fine. Let's just move on to the next question. Okay. Left rotate an array by d places. Isn't it the same thing? Rotate array, given an integer, rotate the array. Yeah, this is the same thing. By three times or 1 time, so it's the same one. I would ask you to basically follow this methodology only so that it's you can just replace the number k by any desired number and this should run, right? Okay, so this is also done. Move zeros to the end. Okay, that's fine. So 0, 1, 0, 3, 1, 2. So everything else will come here and rest will just become zeros. Okay. Okay, so move zeros to the end. I'm thinking of one particular method, of course, O of n. So what will I do if while traversing the array, if I find the 0, then I'll just keep on increasing one count variable. And if it is something else, I will keep another left point variable, which will so I will keep another left point variable starting from 0th index, which will be replaced by all the non-zero elements one by one. So, okay, that makes sense, I think. So let's go ahead and first let me initiate count equals to 0 and also left equals to 0. That's a pointer that I'm taking. And then let's start traversing the array. Okay, length of nums. If it is 0, so if nums of I equals to 0, sorry, nums of I equals to 0, then I'll just do count plus equals to 1. And because, why would I do this? Because at the end, I will add those many zeros. Okay. So, and else, anything else. So, nums of left equals to nums of I, right? So, if I equals to 0 itself is some other number other than 0. So nums of 0 equals to nums of 0. Nothing will change, and I'll just do a left plus equals to 1. Okay. That's it. That's all that will be. After that, at the end, so let's say when every other element has come till the non-zero location of the whole array, and the whole array is traversed basically. So what I'll do, so left pointer is, let's say, somewhere here. So 1, 3, 12. So left pointer is here in this place. So in this place, k till the end of the left till the end of the length of array, we will just replace by 0. Okay. So for I in range of or I think we don't even need that. Nums of, in Python at least, we can just do nums of left till the end will become 0. And then return. This is in place. This is in place. So let's try this. Okay. Indentation error. Okay. Okay. Sorry. Nums of left is this. That's fine. Run. Can only assign on an iterable. Uh, can only assign an iterable. Oh, okay. Okay, I think we'll have to run another loop for I in range of left, comma, length of nums basically, and we'll just nums of I would become 0. That's it. I think we don't even need count. So if nums of I not equals to 0, I think everything else remains same. Because count is not getting used. I thought I'll use it, but I don't need it. So let's just submit. Cool. Okay. So we are good there. Let's tick this one and then move ahead. Linear search. Okay. Given an array R sorted in ascending order and an integer k, return true if k is present in the array, otherwise false. Okay. This is simple. Length of R. If k equals to R of I, true, else false. Right? Okay. 1, 2, 3, 4, 6. K equals to 6. Since 6 is present in the array at index 4, should I? No, it's just true or false. Okay, compile. Okay, submit. Cool. Okay, so this is good. Let's move on to the next question. Linear search is done. Let's go to the find the union. Okay, so let's find the union of two sorted arrays with duplicates. Okay. Union of two arrays can be defined as a set containing distinct common elements that are present in either of the arrays. So input is 1, 2, 3, 4, 5. We 1, 2, 3, 6, 7. Okay, all right. Okay, all right. So I think we'll just to dedupe a list, we can just make it into a set. That's for sure. And then we can sort the array. Set of A plus B, let's say, and then we can do sorted. How about this? Cool. Okay. So that's done. Let's move on to the next question. Given an array nums containing n distinct numbers in the range 0 to n, return the only number that is missing from the array. This 301, 2 is the output. Okay. This is easy. You can just take the summation of 1 to n and then just minus the sum of the elements of array. That's your number. So we can do something like this. So length of nums to length of nums plus 1 by 2. So that's the total. Minus sum of r or nums. Right. Okay. 2.0. Okay, sorry. This will give you the integer division. Cool. Nice. Okay, so this was an easy one. Let's move on to the next one. Maximum consecutive ones. Okay, so we have to find maximum consecutive ones. Given a binary array nums, return the maximum number of consecutive ones in the array. Then break. I think we can take some pointers here. Max count equals to 0 probably. For I in range of length of nums. So okay, so the method that I'll be applying here is anytime the particular element in the array is not 1, break the count and then restart the count, right? So that's fine. Let's just take another count variable to be 0. Max count will be updated after that. So if r of I or nums of I equals to 1, then count plus equals to 1. Right? That's the case. And after that, we will go on else count equals to 0. Okay, that will be restart. If max of count less than count, return, sorry, not return, max of count equals to count, and then we'll be returning I think there's an indentation issue. Okay, cool. So we'll be returning max count. Let's run. I think this should be correct, but let's see. Invalid syntax. Oh, sorry. If it's 1, then plus, otherwise 0. Expected an indented block, sorry. Yes. Indented block. Nice. Submit, please. Cool. All right. So this one's done as well. Let's move to the next one. Find the number that appears once and other numbers twice. Okay. So given a non-empty array of integers nums, give every element appears twice except for one, find that single one. is there any constant extra space? Just take extra space and take a dictionary. Right, so for in range of length of nouns, why is there a indentation error? Okay, now let's try. Okay, for I in range of length of nouns, if nums I not in diction, diction nums I equals to 1, else diction nums I plus equals to 1, right? This is the counts basically. Now for k comma v in items, so key and value pair in the items of dictionary, return the key where value is 1. Yeah, that's what I'll do. So return b for, no, not b, k. K for k comma v in diction dot items. K for k comma v if v equals to 1. Right? Yeah. Let's run. No, invalid syntax. V equals to 1. Invalid syntax. You must implement a solution. Every element appears twice. Okay. There's no edge cases here. Return k for k comma v in diction items. Okay, let's not do this. Diction items. If v equals to 1, return diction dot key. Right? Or return k. K is fine. K, I think. Let's run. Okay, submit. Okay, this is crazy, but okay, let's move on. So that's also submitted. Okay, longest sub-array with sum k. Given an array R containing integers and an integer k, your task is to find the length of the longest sub-array where the sum of its element is equal to the given value k. If there is no sub-array, then return 0. Okay, so it's 15, 10, 5, no, 6, 10, 5, 2. No, the whole array. Okay. I think this also can be solved using, the hash map methodology. So hash map is nothing but a dictionary. It's very easy in Python actually. Okay, so let me show you how I'm thinking about structuring this problem and also how to traverse the whole array. Okay, so let's say this is the array that you have and the number that you have been given, that's 15, right? So what I'm doing, I'm taking all the array elements and keep on adding one after another to a particular variable. And I will compare that particular variable with the given value, which is 15 or k. So here at the starting, it will be 10. And then this is nothing but the cumulative sum, right? So what I'm doing this plus this, and then if you just add, basically you'll get the overall cumulative sum. This is the array and this is the cumulative sum, which I'm actually gathering in a dictionary, and these are the keys of the dictionary, and the value is nothing but the index. So this is 1, 2, 3, 4, 5, right? Okay, so what will I do here? I will first check if the sum is in dictionary or not. If not, then I'll just add it. Add the sum and the index as the value. Now what am I checking? I'll check first if I'm getting, after adding every element with each other, with the previous element, if I'm getting the same sum that I'm supposed to, then great. The first length that I'll get is I plus 1. I is nothing but 1 here, so 1 plus 1 is 2. Length is 2. By taking subarray of length 2, which is 10 plus 5, we are able to get the intended sum here. But let's say if I just increase the sum one after another, if I increase the number of elements, so right now it's 17, then 24, then 25. Now what I'm checking at this moment, I'm doing another step. That's if my count sum minus k is present in this dictionary somewhere. So 25 minus 15, which is 10, and 10 is present here. So that means this summation is somewhere present in the middle of the array. We are letting go of the first elements, a couple of first elements, or one of the first elements in this case, and we're letting go of some of the last elements as well. So the overall sub array resides somewhere in the middle of the overall array. And if 25 minus 10 is 15, which is matching with the intended value, then we will take the index 4 minus 0, that's 4. Total length of subarray is 4, and if you add all these 4 elements up, this is also 15, right? So that makes sense. But let's say now at the end, after keep on adding up all the elements, at the end I'm also getting again the overall value to be 15, or the summation value to be 15, which is again matching with the intended value. So my final length, or the highest length, will would be nothing but 5 plus 1, or I plus 1 in that case, which is 6. So this is I would say this is an extended version of the two-sum problem, where we try to check if the complement of the particular element has already existed in the dictionary or not. Here, rather than two-sum, we are just taking consecutive elements, which is known as subarray. So that's all. I hope you understood. Now let's move on to the main code. So again, take an empty dictionary and then keep on doing the sum one after another. Okay. Let's try once. I think I got it, how to do it. So diction would be a dictionary. So I will take 10, and then its index would be 0, because I have to take the longest sub array. I need the index. So right minus left index will only give me the length of the sub array. So 5 would be first, the element at index equals to 1, right? So keep on summing up. 10, 15, 15 is that. Okay, then length would be 2, one length at least. Then it can be 3 as well. 2 minus 2, 4 also can be there. And then 1 minus 1. Let's say something like that would have stayed. So we could have done, let's say, 2 minus 2. So 4 is another length, but it's not yet the highest or largest length, because there could be, let's say, 1 comma minus 1, saying that. And like this way, the positive number comma the negative number, the length can actually increase, making the longest subarray much higher than the first two, which is 10 plus 5. This is also a subarray whose sum is equals to k, but even then we have to find the longest one. So we have to keep on iterating throughout the loop, or throughout the list. So I think this easily will be taking O of n, but our goal is to make sure that we do not pass or surpass the O of n and make it into O of n square or something. Right, so let's try to do it in O of n itself. So if I just run a simple loop, right, length of nums. For I in range of length of nums, if that is the case, then keep on adding it up, okay? Let's take something, count sum equals to 0, okay? Anything else that I need? Final length, yep. Length equals to 0 for now. And then we'll keep on updating it. For I in range of, 0, return 0. Yes, exactly. We will return length at the end. So that's understandable. If nothing is fitting length, then we'll just return 0, which we have already initiated it. Okay, so for I in range of length of nums, let's just keep on adding count sum plus equals to nums of I. How about that? Nums of I, right? So that's done. Now, if let's say count sum is greater than, if count sum is greater than k, Could be, right? We're continuously adding and then count sum becomes greater than k. Then we have to let go of one element. Actually, it doesn't matter. Let's not think about that. If equals to k, then I'll return, not return. Let's take length equals to I plus 1. Right? So let's say 10 plus 5. So here I plus 1 would become the length. I plus 1 is nothing but 1 plus 1, 2. But if, let's say, count sum not in diction dot keys, diction dot count sum equals to, so count sum not in diction dot keys, yes, diction of count sum becomes I, that's the index, right? Yep. And if count sum minus k in diction dot keys, then length equals to max of length, comma, I minus diction of count sum minus k. Yeah, that's it. Okay, all right. So if count sum equals to k, then length is added, and then length is added by 1. If count sum not in diction keys, then it's added. If count sum minus k in diction keys, then we are doing this. And that's it. That's all we have. And then at the end, we will return the length. I think that's the final structure. Okay. In range length of nums. Okay, I'm sorry. I just changed this to nums because I've taken nums everywhere. Okay, so this is making sense. Let's submit. Cool. All right. So we are done with this problem as well. Let's just move to the next one. Longest subarray with. Okay, so this is the same problem. Longest subarray with some k. What's the difference? Longest subarray with given some k positives plus negatives. Okay, positives plus negatives value in the array, I believe, and only positive values in the array. But I think the way we have done it, and since in the example also there were negative values from the first itself, so I'm not sure what the question means. But even then, I think this is a good enough approach. Try to do that. Try to reiterate the approach that I just showed you in Excel, and try to think about all different kinds of problems, or even solve different kinds of subarray problems, which can include, let's say, two sum methods, or it can include some sliding window method. Using those two, we will try to solve all these kind of array problems within O of n at max. Right? Okay, so that was all for today, and hope you learned something. Stay tuned for the next part.